This is Dr. Mears, and today we're going to be talking about spread. We're using SOXY. This is shape, outlier, center, spread, and context. So we're talking about spread today. We're going to be going back to the Cheetos example. And the Cheetos example, we had 17 numbers here. And it was about me opening up a bag of Cheetos because I felt like they were underfilling them. So we're going to find out the spread of this data set. If you want to know the shape and outliers, you can visit those videos for shape and outliers. Let's write down some information. This has a mean of 17.17 Cheetos. It also has a median of 16 Cheetos. We found that. We also have an IQR of 6.5 Cheetos. And we're going to put down the standard deviation, which I'm using the sample standard deviation because it's based upon my sample. Look at that. I'm trying to talk and write. Which is 6.57, which came out kind of weird. Bear with me on that one. So let's talk about our two measures of spread that I just wrote down, IQR and our standard deviation. Let's first talk about IQR. When we compute IQR, you will have noticed that we used it to talk about our outliers when we had our outlier rule. And what IQR is taking quartile 3, which is 75% of the data, and subtracting it from quartile 1, which is 25% of the data. And what you get is you get the middle 50%. Middle 50% of the data. And so what we did for our IQR, when we looked at our outliers, we took, I believe it was 19 and subtracted 12.5, and that's how we found that our IQR was 6.5. Now, putting some context with that, this means that the middle 50% of the number of Cheetos varies by 6.5 Cheetos. And that's going to be, if you drew a box plot, you would see that middle 50%. So let me write that sentence for you. So this is what the IQR sentence is. The middle 50% of the number of Cheetos varies by 6.5 Cheetos. So this is what IQR means. It looks at that middle 50% of the bags that I opened. We know that they're going to vary by 6.5 Cheetos. Now, remember, my maximum was 38, and I believe my minimum probably was about 10. Okay, so that's IQR. That's a measure of spread. We use IQR when we employ the median as center. So IQR and median are best friends here. So when you're talking about IQR and median, talk about them together. And if you're looking for a visual display, we're usually going to make a box plot with this. And when do we use IQR median in a box plot? That's when our data is going to be skewed. So if you have a skew, whether it's right or left, you are going to think box plot, you are going to think median, and you are going to think IQR. That is your little flow chart for you. So skewed right or left, let's go box plot, let's go median, let's go IQR, and that will help us to explain our data. So that's using IQR as spread. Let's look now to standard deviation. I'm actually going to write S over again. So we're looking at standard deviation. Okay, here we go. And standard deviation, there's going to be two different numbers that your calculator is going to give you. They're going to give you sigma, which is lowercase sigma, Greek letter, and this is going to be the population standard deviation. S is going to come from your sample. This is sample standard deviation. So because I obtained a sample of Cheeto bags and opened them all up and counted the Cheetos, I'm going to look at S. So that's why I wrote down that our sample standard deviation was 6.57 Cheetos. What does this represent? This represents how many Cheetos away from the mean number of Cheetos that we have. I feel like I'm using Cheetos a lot. I kind of want some Cheetos right now. So let me show you. So if we are 1 standard deviation away from the mean, represents that we are 6.5 Cheetos away from our mean of 17.17 Cheetos. So if you are 1 standard deviation, it's a standardized measurement, away from the mean, this represents that we are 6.5 Cheetos away from our mean of 17.17 Cheetos. So we can say, oh, I'm 1 standard deviation, so I'm 6.5 Cheetos. Then we can actually have 2 standard deviations. So if I'm 2 standard deviations, then you're right, we would multiply by 2, and I would be about, I'm thinking 12.25 Cheetos away, if I did my calculations correctly. And now, 13, I'm sorry, that was wrong, 13. So let's actually write that up on our sheet. So if I'm 2 standard deviations away from the mean, it represents that I am 6.5 times 2, which is 13 Cheetos away from my mean of 17.17 Cheetos. And I'll show you all that. So 2 standard deviations away from the mean represents that I am 13 Cheetos away from my mean of 17.17 Cheetos. We can even go further. We can go, what do you think? Yeah, you guessed it, 3 standard deviations. And so 3 standard deviations is going to be 6.5 times 3, and putting in our trusty old calculator, we get 19.5, which equals 19.5 Cheetos away from our mean of 17.17 Cheetos. So 3 standard deviations is 9.5 Cheetos away from our mean of 17.17. So as you can see, we're getting further and further away the more standard deviations we go. 1 standard deviation is 6.5 Cheetos away from our mean. 2 standard deviations is 13 Cheetos away from our mean. 3 standard deviations is 19.5 Cheetos away from our mean. We're actually going to be exploring standard deviations a little bit more. However, when you see standard deviations, you say, well, what center do we use? So what we're looking for is a symmetric graph. You're probably going to see maybe a dot plot would be good here, or a histogram. Those are the types of graphs that you would probably definitely look at. So you see symmetric, you're looking at dot plot or histogram. When you see that, you need to employ mean as your measure of center, and you need to employ standard deviation as your spread. So if you have a symmetric distribution, You're probably using a dot plot or histogram. Employ your mean as your center and use standard deviation as spread. I hope this helped explain what standard deviation is and what IQR is. This is Dr. Meir signing out. Thank you.